This is a good question. There are a lot of ways to think about it and to solve it. Let me start with the way that I think that the textbook would want you to solve it. Um, what are we looking at here? What do we have a picture of? Well, yeah, there's inequalities, there's shading, there's all this stuff, but at bottom, these are about this question is about lines. So get back to basics, right? We can see that there's two lines that are graphed. Graph the lines. Right, look at the answer choices. What are the equations of these lines? You have to know that. You have to be able to recognize y equals mx plus b when it comes up on the test. So if you start from that, you can ignore the inequality piece. And this is advice I've given on other questions for other videos I've done, and I think it's generally good advice, that inequalities on the SAT more often than not are just a distraction. They're a way to intimidate you and make you think that the question is really hard, but very often they're not important at all, or they're like a secondary piece of what's going on. So focus on the other stuff first. So let's just treat all these inequalities as if they were y equals. So if we look at the questions then, we can see that we've got some lines. We can worry about the x and the 7 one in a second, but we can even just use this one, y equals 2x plus 1. Is that what's graphed? Well, y-intercept, the b is 1, and then the slope is rise 2 over 1, rise 2 over 1, right? So slope is my m, and b is my y-intercept. Checks out. Whereas this is just not even really a line. We could get back to basics here too by dividing by 2, and then we'd have y is equal to 1/2 x, but this doesn't make any sense. First of all, the y-intercept is not 0, so that doesn't work, but also the slope here is not 1/2. It's up 2 over 1, right? Rise over run is how we get slope. So C and D, just without even thinking about inequalities at all, C and D are just wrong. They don't match with what's happening. So from here, you can just try to narrow your focus. Look at what's different, right? The y is less than 7 is the same in both. So I don't care. But the inequality is different in these two. So now the inequality does matter. But it's okay. We ignored it at first. We did a good job of eliminating some answers. And now we bring it back in and we say, okay, what effect does it actually have? Now, if you've memorized how these like shading things work, it's actually really convenient when the equation, the inequality, is in a y equals kind of form. Because then we're just shading to include the y's that are either greater than or less than the line that we drew. So we drew a line, here it is, and then we're shading what? Above it or below it? Well, look at your y, right? I mean, here we saw that the y-intercept is 1, but what are the y's that are shaded, right? 2, 3, 4, 5, 6, those are y's that are greater than the line that we drew. So greater than should be b. Now, this gets into the strategic way of handling this. So it's very good if you can memorize how inequalities work and how shading works. And I should talk about the y is less than 7 as well, right? Y is less than 7. What are the shaded parts from this line here? Look, it's down, it's below, it's less than the y that the line is at. So it's very logical when the y is kind of all on its own. So even with C and D, we would want to get the y by itself so we can understand it better. But even without all that, remember, a shaded region like this is a solution set. It's a container of points, and those points are supposed to match our inequalities. So if you're ever unsure about what's going on, again, you don't really have an excuse here because you're supposed to recognize that all of these choices are equations. And what do we want when we have equations? We want points because we know that our most useful strategy is to plug points into equations. So what points do we plug in? Well, the line has some points on it, but I'm not interested in that because this is an inequality. So I'm interested in the points that are kind of mixed in here. So let's pick something kind of random seeming. Let's do this point right here. Let's see if I can really make that pop. There you go. That is the point 5 or 0, 5, 0, 5. So what I would do is I say, okay, does 0, 5 work in these equations, right? It's shaded, so it's supposed to be a valid point. So it works in all of the top ones, right? So y would be 5, so 5 is indeed less than 7, so that checks out. And then even on the bottom with the x's, right? 0 is indeed less than 7, so that works out too. But let's try these equations, or these inequalities. So if I turn this back into an inequality, let's see if it fits, right? So 5 is my x, or is my y, and 0 is my x, so 5 is less than 2 times 0 plus 1. So 5 is less than 2 times 0 is 0, 1. Well, that's not true. 5 is not less than 1. So what that means is that this inequality is wrong because it produced a statement that is not true. It's supposed to include this point. It's supposed to be a good thing, and yet it produced a bad thing. And if we switch to choice B, we could see that it's definitely better when we have a different sign, right? Because then it would be 5 is greater than 2 times 0 is 0 plus 1. And that's true. So we know that that point is included. Now, if we did this, I'm going to cut the video here, but we could check points in the other wrong answers as well. So if we didn't even know from the start where to begin, we could do this plug points into equations in all the choices. And what usually happens with inequalities is your first point that you pick will work in a couple of equations. And so you'll eliminate some stuff, but then you'll have to choose new points to kind of get down to one answer. But at least if you've eliminated a few, you can kind of see the patterns and start to recognize, like, okay, what's another good point to pick that's going to make the difference here? What's going to get me this one to be right, but this other one to be wrong? So plug points into equations is a really useful strategy because it works on so many different kinds of things, including inequalities where the points we're plugging in can be anywhere from the shaded region. They could also be from without the shaded region, and we could see if the point fails, but we're not going to worry about that for now. Plug points into equations when you're unsure what to do, and you notice that you've got equations, and you notice you've got points.